So I thought I'd do a bit of a summary before I get into the detail. Looking at the top slide assembly with the tool posting, I originally was unsure if that was the original tool post. By the looks of it, it was. So I'm going to clean it up and use that for now. But I want to get some kind of quick change tool post, but that's down the line. Wanted to basically to just have a brief discussion around what actually matters in relation to scraping up this. Obviously we know about dovetail slides, and we know that they're supposed to be in alignment with a good bearing contact. From a cutting point of view, you want to make sure that the cutting tool is well supported and that the forces going through the cutting tool are transferred down through the tool post, through the slides, it basically into the saddle and then into the lathe bed. That's what's absorbing all that vibration and the cutting forces. So again, you want a good bearing contact where there's a moving face. You want a good static contact where there's a static face. But above all, you've got to keep it all in alignment. So we've got a plane of the bed running that way, and we've got the plane of the cross slide running that way, and we've got those set up bob on, and I'll cover how we've checked those in a moment. So going through the top, through the sandwich layers, you've got the interface between the tool post and the top of the top slide, the interface between the top of the top slide and the bottom of the top slide, and then between the base of it and the cross slide. So you've got 1, 2, 3 positions, all of which need to be coplanar that way and coplanar that way, and therefore all the radial positions in between. So the starting point, because of the wear that I found on it, was just to give myself something as a sporting chance of picking up a plane that's on it. Then I can make adjustment to that plane. So they started off with scraping the bottom of the tool slide, tool holder. It was originally just printed on the 4 corners, and I'll show you a bit about that. That's made of steel. It doesn't appear to be particularly hard. It's got some weight to it. And I've scraped that to give me good contact. I've then used that to print that face. Again, there was very limited contact. I've got it to a stage now where I've got somewhere in the region of about 50% contact, but there's an alignment issue. So the next question was, is the alignment of that coplanar with the slides underneath? And the slides underneath, what we started off with pretty worn in this area and down this face, not so much at this end. So we scraped a plane on that by printing it on the surface plate to give us bearing, and we then went ahead and scraped these to give us bearing. We then set this up and we checked to see, are these running coplanar? And we've recorded the errors on those, so we now know where the adjustments have got to be. However, we then start to get into the problematic bit. When I removed that, I inked the bottom of this roughly, and you can see there's a hell of a lot of ink still on there, and I then printed this, and with the best will in the world, the only additional surface contact is that far corner there, that far corner there, corresponding to these positions. And that is the extent of the wear, the if you like, how the forces are transferred through. Because that's a static member. Whilst you undo the nuts, you rotate it round, bolt it back down, it becomes a static member. So you want as much surface contact as you want, and you're not talking about points per inch. You can have 6 or 7 as long as it's 70 or 80% contact. But because of the way that the divisions have been rebated into this face, you've got a big ring where you can't have any contact. So that leaves me with a bit of a dilemma how best to pursue that. The next part of it is that I want to make sure, well, I won't put that on at the moment, that this, when it's in this position, that these slides are coplanar with those. and there's a small error there. And then when I rotate it round, so it's in that position, there's an error there. All of that relates to this seating position. So I'm pretty sure I'm going to make the corrections by scraping in the bottom of this. A, to give me that last bit of contact, but B, to bring me back into alignment. The problem is I've got to, I can scrape that to give me alignment, but then to get some kind of reference in terms of a flat plane for it to print on, I can't print it because of this boss unless I print it on here, which then necessitates me scraping the top of this. What I was concerned about was, didn't want to start scraping this if I was going to lose these graduations. They're 4 thou below this surface, the highest point of this surface, and there's around about 2.5 thou variation over that area. So I've got to basically get that to give a good printable master surface without taking more than 2 thou off, so I still leave these rebated, and then I can print, oops, wrong whip, I can then print that on it and check the alignment of that. Bit of a long-winded explanation, but it's important that you understand the sort of thought, well, I think it's important that you understand the thought process behind it. I could just bang it all together and accept the fact that when I spin the thing round, I've got to check tool height, and as the tool's travelling along, it could go plus or minus 1 thou over its starting position. I don't think that's acceptable. I want to get it right, and it's been an education actually going through the process of it. Right, enough of me blathering on. And what I'm actually going to do is do this in two-part video. So you've got much of the explanation and the basics of the scraping back to giving me alignment, and then I'll do a follow-up one where we do the finished scraping to give the contact and hopefully get the thing built up. There is, on this tool holder, there's a bit of damage where the tools would protrude. I don't know whether you can see that on there. I want to try and clean these up, so I might refresh those with just nip a bit off, just so the tool is actually supported where it's coming out. Well, I've just stoned it off and it's like a bloody moonscape, but the 2 is the same stamp that I found on that, so it must have been the original tool post. Anyway, I figured as all the vibration from the tool cutting is going to go down through this into that, and then into the lathe, it may as well be a good contact surface. I assumed at once originally it must have been a quality machine face. I think these are indexing positions, and the only corresponding dint is that, but there's no pins or anything, so that might take a bit of thinking about. Somebody's obviously took them out, decided they didn't want them. Right, so give it a rub and see where we're at. Not great, I think, is the answer. Right, I'm going to give that a good scrubbing over and see if we can get some contact. So that's the second rub. It is steel, but it's not hard, or it's not hardened. So keep going. We want sort of at least 50% coverage. Easy way to tell it's steel is when you look at the little tiny splintery needle filings. Those little buggers go straight in to your fingertips. That's after 6 cycles. You can see it's already getting a lot better, and it's hinging nicely now, almost above each dot. I just want to get a bit more between these areas. There's a good video on YouTube by a young German engineer. I think it's called Scraping Carbon Steel, and he's undertaking some investigations into different geometry of the cutting edge of the scraper, and he makes himself a nice straight edge out of laser cut carbon steel, which he then scrapes into the finished surface. So if you're going to do a lot of steel scraping, take a look at it. I'm just using the same tool I've used on the cast iron. It works. You get a bit of chatter, but as I'm rubbing it down afterwards with a diamond stone, that chatter disappears. That's when you got to be careful, when you go dig in and then you just make it bigger by hammering at it. You got to push a bit harder, and you're not trying to get too deep. So that's when you end up with a ridge. And don't sweep the shavings off with your fingers, otherwise you look like a porcupine afterwards. You'll notice I'm going over it at different angles quite frequently because it's steel. What I've found is you tend to get more ridges when you go along, and it tracks along, it doesn't cut through as easily, so you're more inclined to get chatter basically. So if you cross your cuts a bit more often, it reduces that. Can't be far off at that. Don't need any lubricant for cutting. So it's getting there now. A little bit hard on at these two outside corners. but not enough to make the hinging change. Rinse and repeat. Right, so the next job is get the tool post seated onto its seat, and then we can set the thing up and see how far out of plonk it is to the cross slide plane. First job's deburr it, and then we'll try and get a rub off it. That's had a lot of ink on the bottom of the tool post, spun it around a lot. So now what I'm going to do is basically take it down so I can then pick up the corners. So just checking with the thou feeler gauge again. We've got a couple of thou at each corner, which corresponds with the material we've took off there. So basically, as it was being used, the corners of the tool post have been hammered down with the forces of the cut, pushing them down below. I've now flattened off the bottom, but what they'd actually done was bedding themselves onto the cross post, tool post. But at some stage I'm going to probably remachine these flat, probably do them in the shaper, so that the tool has got full support all the way across. I guess also if somebody's cranked down the corner post screws, that's going to push it down as well. There you can see that's where they're going in. So just checking that the cross slide is moving across in a single motion, not rising or falling. So it's, if you like, it's coplanar at 90 degrees to the bed. Alright, so that's that done. I'm happy that that's not moving much. We've got there's a bit of wobble in the stylus. Right. So I'm alright with that, that's flat. So the next thing to check is that the plane of the top slide is also true in this direction. So I'm going to reset it up from the start of it. I don't need to put it on a straight edge because I've already scraped the face flat. I just haven't checked that it's perpendicular to its base. Sorry, that it's coplanar to its base. Because I can't do that because there's a boss on the bottom, so I can't stick it on the surface plate. Now I'm expecting a rise on this. And that's the end of the travel, so that's flat as well. So if I now stick the top piece on and we traverse across the tool seat, we'll see the error on that. Bear with me. So I've just took a parallel across the roughed in seat for where the tool post sits, and what I'm going to do is wind the cross slide across, because we know that the two planes between the cross slide and that are already parallel. So you can see straight away that's a thou, thou and a half, 2 thou, 2 and a half, 3, 3 and a half, 4, so that's 5 thou of rise from the far corner. Now if I spin that round and put it crossways, I'll get another reading that way. and then basically I want it so it's flat and level. So there's quite a bit of material to shift off that at the moment, which just goes to show it was a worthwhile exercise looking at it. So that's the setup for checking the other plane. So I'm still traversing it backwards and forwards with the cross slide, but I've now got the top slide at 90 degrees, and I'm looking to see if it should run coplanar with the others, but we know it's not going to. So it's actually falling away. There's 2 thou. That's 3 thou and I'm out of traverse. So we've roughly got something like 5 thou to come off down to nothing. And the lowest, I need to check the dimensions again and see where it's low and where it's high. But that's why I've only just started to rough it in. I wanted to get a reasonable flat seat to stick a level on it before I start actually trying to get decent contact, because I want to know that the plane I'm scraping to is parallel and coplanar with the plane that it's operated on. If it's not, as it moves through one plane, it's going to be making an adjustment on the other, which is going to completely mess up the geometry of everything. Hope that's clear to follow. I will be asking questions at the end. And the final piece of the puzzle is to check the ways of the slide for the compound across them. So I've got the parallel set over them. So whilst they're scraped and they are coplanar, there's 3/4 of a thou out of alignment to the base of it. So these are coplanar, and when it's in that position, these are coplanar. But at 90 degree, with this 90 degrees round, I've got 3/4 of a thou variation across the width, which I need to address now. I need to sit down and have a bit of a think, cup of tea, and work out the plan of attack. The seat for the tool shows 5 thou variation around it. Some of that 5 thou is this 3/4 of a thou, so let's say there's 4 thou variation, so that needs sorting as well. So after much measurement and deliberation, what I've concluded is the following. I know that when this sits with its mating faces on it and sliding backwards and forwards, when we're pointing in that direction, we're good to go. However, when I rotate it around 90 degrees, there's an error of roughly a thou in 4 inches, or the width of that, which is measured across there. So it has to be the seat between that this sits on, which is this area, and this area. That's the first one. So I need to basically massage that seat, including that, and make sure that that is coplanar with the bottom of the dovetails. I know that it's not a million miles out on this, but I do suspect there's a bit more of an issue on here. So I need a reliable way of measuring that, which I'll come back to. The next problem is that the tool post base is quite a long way out from that as a plane, which is the dovetail face that it slides on under there. So I need a reliable way of measuring that in relation to that plane. So it's going to be a bit tight trying to do it on my small surface plate, but the idea is I'm going to flip this over, stick it that way down on my surface plate with a gauge on a bed which we've just bought, and running it round, and then basically scraping this down to give us a flat plane, which then brings us the problem of how do we actually print that, because it's got a raised boss in the middle. And the only real way of doing it is using this, My concern from scraping this is I don't want to lose any of these graduations. So what I am going to have to do is take this off again, drop the plate out. I've already deburred it. I'll run it on a print, see what kind of distribution I get, and I know that this area, about to there, needs to be flat and true to that. So that's my starting point, and then slowly build up the sandwich from there. And then the last face will be that brought into parallel or coplanar with that face and that face. So yeah, that's how things are looking at the minute. So yeah, quite a bit of corrective work to do to get these misalignments out of the way, but I can't think of another way of doing it, and yeah, I was hoping to not have to do it, but there we go, it's got to be right. So moving on. Oh, this is the first time I've used this plate after scraping it. So it's 18 inches, I think it is, 18 inches square. I don't think it's 20. So we're up on parallels on the top slide, and we're checking these two corners are, or appear to be, pretty square. So I'm going to sit in the tripod and we'll have a look over it. We're half a thou out there, but the surface is not great, you know, that's down, there's scores in it, all sorts. I could put another parallel over it and even it out, but I actually want to see the variations. So that's the tailstock front. That's the tailstock rear, that's 7th thou. Yeah, you're getting a basic idea there. If we do now, if we spin it round and do the headstock side, again I've took that as kind of like the midpoint. It's even at both sides on the headstock and the tailstock. Alright, we've got what, 7th thou. So between the front and the rear of it we've got 7th thou. There's a little bit of creep when you would set the locking thing. So let's bring you in a bit closer. So what we're measuring now is the variation over the seat for the compound slide. So that's the left to right variation. Like I said, that was averaged out, not a lot. Which is looking as if the variation is more to do with the condition of the surface. Yeah, it is. So that looks like what, a thou. So I'm reasonably alright that that's flat enough. It would benefit from a scrape to make it a decent contact surface, and then look at scraping its mating face. Or we actually do it the other way around. The only other thing I could do just for completeness would be to sit the seating face on the parallels and then check the bearing face against that. So I'll set up for that now. So we're checking for the variation between the seat and the bearing face. You can see it creeping up. That's a thou. So there's, let's call it 1 1/4 over the span of the bearing face, which by the time it's reached the end of this bearing face, you've got 1 1/2. So that needs addressing. I have checked it both sides and it shows the same. The only other thing I want to do is stick a parallel across and see how it compares that way. Or I could flip it over and run the DTI along that. That's probably easier. Oops, here's the wrong one. So that's 3/4 of a thou higher on this face. Ooh, this is going to be tight. So basically this side's 3/4 of a thou higher and this end is whatever it was in the earlier measurement higher than the front. So a bit of work to do. Bit more of an insight. With that mounted on the cross slide and nipped down with the 2 nuts either side, and when I print that I get a different print to when it's not nipped down, and the difference is when it's nipped down it prints clearly at the ends, leaves me a hollow gap in the middle. When it's not nipped down I've got even print all the way around, so it's obviously getting pulled down. So what I thought I'd do is crudely put some glue on here, put it down, not nip it, but just give it a rotation and see, and you can see where the base has been rotating around. What's surprising is actually the level of contact. Let me just get another grip on that. So you've got great contact at the arse end of it. So as I was trying to point out, we've got good contact around the back end of it, but all the tool action is at this end. This big blank area is where that's been recessed 5 thou. So there's no contact in this ring. So all the tool pressure goes down through these. So pretty sure that, you know, even if I scrape this round, the best I'm going to get is a contact ring there, and then basically from that point out to the corners, which would be better than it is now, but it's not ideal, but that's how it was made.